Hello everyone, and thank you for joining us today. My name is Tracy Cook and I'm the online media manager for ModernAnalyst.com, the premier community for business analysts. I'd like to welcome you to today's webinar entitled Requirements Management Best Practices. And today's featured speaker is Carl E. Wiegers, Principal Consultant. Today's webinar will last approximately 60 minutes, including the question and answer session at the end of the webinar. Please be sure to submit your questions in advance using the questions feature of the GoToWebinar software. And now I'd like to say thank you to Cover Software, Inc. for sponsoring this event.
Thanks, Tracy. Hopefully everybody can hear me okay. If not, I'm sure someone will let me know. So thanks to everybody for joining us today. What I'd like to do is first show you just a little bit about how you can reach me if you wish to. This slide gives some contact information and also identify some of the books that I've written. The book on the right end is kind of interesting. A few years ago, I wrote a book called Pearls from Sand, a memoir of life lessons, which was a lot of fun to write something completely different from my software books. And in fact, I've just finished writing my first novel called The Reconstruction. So that was even more fun. And with any luck, in a few months, you'll be able to find that at all the finer bookstores near you. You might also want to visit the goodies page at my website, processimpact.com, shown at the bottom of the slide here. I'll say more about that in a moment. There you can download a wide variety of templates and other useful work aids, some of which I'll be mentioning as we go along. Now, the material that I'm going to be talking about today is largely found in the third edition of my software requirements book, co-authored with Joy Beatty a few years ago. And also, here's a special offer just for our attendees today, that if you're interested in the Process Impact Goodies collection with a large number of these templates, webinars, spreadsheet tools, all sorts of things, then there's a discount code you can enter. I'll show this again on the very last slide. Discount code GOOD17 will get you 25% discount on that for the attendees today. So I've been interested in improving software requirements for nearly 30 years, and one of the things I learned early on is that we have an immediate problem when you start talking about requirements, and that's simply one of terminology. Some people call the whole requirements discipline requirements engineering. Some just call it requirements. Some call it all requirements management. And here's how I think about it, and this is what we'll be focusing on today, is this mindset. I subdivide the domain of requirements engineering into requirements development and requirements management. And requirements development is really all about deducing, capturing, and then agreeing on a set of functional requirements and also product characteristics that will let you achieve your stated business objectives. Requirements development consists of multiple activities, and these are not a linear sequence of activities you perform, but they're all interleaved and you do them in small chunks. But we do some requirements elicitation to talk to the right people, read the right sources of information to understand what the needs are. We need to do some analysis, which involves decomposing requirements into lower levels of detail, representing them graphically with appropriate visual models, prioritizing, and the like. And then we need to take what we've learned and record that in some form, and that's what specification is about. And you can do this in a lot of different ways, of course, but specification is really where we get a body of information that will help make sure everybody involved with the project is pointing in the same direction, working toward a common goal. And we need to validate those requirements to make sure that they are, in fact, the right requirements, and that we have confidence that if we implement this set of requirements, we will, in fact, achieve our business objectives. But what I want to focus on today is this category of requirements management. Requirements management really deals with what do you do once you have one or more requirements in hand? The things that we do not to get the good requirements, not to write the requirements, but to deal with them over their lifetime, the lifetime of the project, and often beyond. So that's what I'm going to focus on today. So the principal goal of requirements management is really to agree upon a set of requirements that can be used as the foundation for all of the development work that follows, and to make sure that those requirements are accurately implemented in the product. That's what we're trying to accomplish through the requirements management practices. Now, when I talk about a set of requirements, that could represent 100% of the final product, like in a pure waterfall development approach, or it could represent just a few percent of the ultimate product, like in an incremental or agile development approach. Doesn't matter. Whatever set of requirements we're talking about that we want to manage, whether it's for an increment or for an iteration or for the whole thing, that's what we want to deal with. So here are the key practices that can help you achieve these requirements management goals. We need to start by defining a requirements baseline, and I'll be going through each of these in turn as we go along here. Now, we're going to record our requirements in some form. I'm going to call those documents, but of course, when I refer to a requirements document, that doesn't necessarily have to be a traditional word processing document. That's what most people are still using, and that's fine, but you can store requirements in a variety of forms. Word documents, Excel spreadsheets, index cards, databases, a wiki, a bunch of sticky notes, although I don't think that's a very good idea. And of course, a requirements management tool. So there are a lot of ways you can store sets of requirements, but I'm going to call those documents just for convenience. And we have to manage versions of not just sets of requirements, but even individual requirements within each set, perhaps. We need to have in place, and it needs to work, a central change control process, because change happens and we just have to realize that and deal with it. Doesn't matter whether you like it or not, that's just the way the world works. Part of your change control process should be to do some impact analysis before you decide to accept or implement a specific requirements change. And so we're going to be talking about each of these and seeing a little more specifics as we go along. You might want to store not just the statement of some intended functionality, but also requirement attributes, some richer set of knowledge about each requirement. One of those might be status, so that throughout the course of the project we can monitor the progress of each requirement as it goes from concept somebody had one day to finally implemented and verified in the product. We want to maybe trace the requirements into the downstream deliverables that we create, such as bits of design, chunks of code, test cases, other things that you create because of each requirement. So tracing requirements, or requirements traceability, is all about connecting those little bits back to each requirement that led to them. And finally, you might want to think about using a requirements management tool as a replacement for other less flexible ways to store requirements. So these are the practices that we'll be talking about here for the next 45 minutes or so. So let's start with a baseline. Now, you may or may not be familiar with this term. A baseline is really a configuration management term. A baseline of anything represents a snapshot in time of some work product or set of work products that serve as the foundation for the subsequent work you do on the project. And they also serve as the starting point, the reference point for changes that you have to make. So the baseline is really an important idea, and we can define it kind of formally here as a reviewed, approved, and agreed upon set of requirements that are committed to a specific product release. And again, that release could be just an iteration, say. So here's what I think of as a requirements baseline, is this definition, and all of those words are important. I think it's important for people to review a set of requirements to make sure that we all have a common understanding of them and that they're as good as we can make them. I think it's important for the appropriate key decision makers to approve and agree upon a set of requirements. Those are both very important issues, and they really aren't quite the same thing. But that's a really important notion. Now, a lot of you probably have some kind of a sign-off or approval process that you go through for your sets of requirements. But what does sign-off actually mean in your organization? Really, sign-off is a matter of approving that baseline, but sometimes sign-off doesn't mean anything. It's just a little empty ritual that people go through because we always have and we think we have to. Sometimes sign-off means, well, a manager was given a form with his name on it and a line above his name, and he signed on the line because otherwise nobody will write any code, but that doesn't mean I read it, doesn't mean I understand it or agree to it, I just signed so we can keep going. Well, that's not very meaningful. And I think sign-off ought to be meaningful. I think the idea of agreeing on a baseline that says, here's what we're going to do, and here's what we're going to have when we're done with this chunk of work, I think that's a really important foundation for a successful project. So when we define a baseline, there are several implications. For one thing, that's when you start formal change control. And formal can be however formal you wish to make it in your environment. But change control is remember, it's a delta against the baseline. So if you don't have a baseline, how do you even know if you're experiencing changes? If we never agreed that, yes, here's what we're talking about doing, then how do you make sure we understand what the changes against that are and what their implications are? So when we define a baseline, managers start making schedule commitments, and they start determining the staff and budget and other resources they need to meet those schedule commitments. So this is pretty important. So I would suggest that you have in your organization some kind of approval process for sets of requirements, and it ought to mean something like this. When someone signs on the dotted line that says, okay, I'm approving this, I'm signing off, it ought to mean something like the following. They should be saying, I agree that this set of requirements is a foundation for the next stage of work to begin. I further agree to make changes after that following our change control process. And here comes the part nobody likes. I also agree that changes in those requirements might demand that we renegotiate commitments. Nobody likes that. Everybody wants change to be free, and the sad fact is change is never free. You have to make sure all of your partners and stakeholders understand that. Even the act of talking about a change and then deciding not to do it takes time. It costs something. Change is never free. That doesn't mean you can't do it or shouldn't do it. Often there's huge value in making changes. But just understand there are some implications. There are some costs. So that was our first practice, is defining a baseline. Now we should think about version management. Maybe you've been in a meeting where somebody said something like, oh, the customer just canceled requirement 27. And you say, wait a minute, I see requirement 27 still at the top of page 5 of my requirements document. What version of the spec do you have? And somebody else says, oh, I have version 3.1. What do you have? Oh, I have 3.1 also, but it's different from your 3.1. Now I don't know which one of these to believe. Now I've talked to people who have actually had that conversation, and it's not a very fun thing to do. So it's really important to place your requirements documents under version control so that we keep the documentation in whatever form you've made it current, and make sure it's communicated to everybody. Each one of you should be able to go back to your office and without any ambiguity find the current set of requirements for whatever you're working on. And you should all find the same set if you try to do that little experiment. One way we can try to do this is to make sure that only certain people, authorized people, typically a business analyst has this role, can update the requirements. So everybody has read access to it, but only certain people have read-write access. And this is one problem I have with using wikis for requirements documents, depending on if you've set any permissions. But if everybody can change a wiki, then basically that's an invitation for chaos, not for making sure that everybody is being clearly read in and communicated on the changes that are made. So problems arise when project team members are unknowingly working from different versions of the requirements. So you want to be able to make sure that everybody knows the version of every requirements deliverable that gets circulated, and ideally of every individual requirements as they evolve over time. So automated tools are the best way to do this, but manual identification methods and the discipline to use them can also work. So the best bet is to store the requirements in some kind of a database. And this is really what commercial requirements management tools are intended to do. And that can basically solve this problem. Now, maybe you're not ready for a tool. We'll talk more about tools a little bit later, and there's lots of reasons why you might not choose to do that right now. So the next best thing is to store individual requirements documents in a configuration management system. So just like with code, you use check-in and check-out discipline to make sure that we are keeping track of the changes that are made and communicating to those to everyone who needs to know. And we're also keeping historical versions, because sometimes you do need to go back to something that maybe you changed once and said, no, we had it right the first time, or it was out of scope, but then it's back in scope. Now, here's a little manual scheme that you can use. I mean, if you're doing what a lot of people are still doing, which is fine, creating requirements documents that you manually label and identify so people can tell them apart, we can make that work, but there's some things to watch out for. I would suggest you avoid documentation identification schemes that are based on dates. Is it the date that the document was last printed? Is it the date that it was last revised? What if we change it and then don't print it, but we don't change it, but then we print it and get a different timestamp? That gets confusing. A lot of people use an X.Y scheme for assigning version IDs, like version 7.2. And I've seen schemes that were kind of scary. One place I went when I was a consultant, said that if the number to the right of the decimal was odd, it was a draft version, but if the number to the right of the decimal was even, then it was a baseline, approved version, and I find those things very confusing. So here's a scheme that I find works very well, not just for requirements documents, but for any kinds of deliverables that are going back and forth, undergoing revision, living documents. The first document, or first version that I would create, I would always call version 1.0 draft 1. Very explicitly a draft, very explicitly numbered. And then if I have to change that and maybe get some comments back to somebody, that's version 1.0 draft 2. And we go on through that however many drafts we need to until we get to one that we agree on, and that's now version 1.0 approved. Well, life goes on and we probably have to make some changes later on, and so now we've got the next version might be either 1.1 draft 1 for a small change or 2.0 draft 1 for a larger change. So if you can get into the habit of and the discipline of modifying these version labels as you go along in this way, then I think it will greatly reduce any confusion that people have from just, say, incrementing numbers. That really has worked very well for me. So the central part of requirements management is really change management or change control. Sometimes people don't like the term change control because it sounds like we're restricting changes. You can't make changes. And that's not really the intent at all. The intent is to make sure that when we make changes, as we will and as we must, we do that in a thoughtful, controlled way with the right people making decisions at the right time to make sure that we've incorporated appropriate changes in an appropriate and effective way. That seems sensible to me. And the reason we want to do this thoughtfully is because uncontrolled changes can cause lots of problems. For example, if one person thinks that there's a change they're supposed to make and somebody else doesn't think there's a change that they're supposed to make, then people's work can get out of sync because one person might make a modification, someone else doesn't make a corresponding changes in their deliverables because of that modification. People can get confused and overwrite each other's work. One person might make a change and someone else comes and says, oh, I'm supposed to put in this new change, and they overwrite the first person's work. You can end up with people working on obsolete requirements to implement them, which is not good, that's wasted effort, or obsolete versions of requirements, in which case they're going to have to fix it. And I hate rework. Rework is something I always strive, both in my professional career and in my personal life, to try to not do. I like to try to get things as close to right as I can the first time so that I don't have to fix it. Why is it in software? Maybe you can help me understand this. We never have time to do things right, and yet we always seem to have time to do them over. I've never understood that. So uncontrolled change can cause a lot of chaos on a project. So I think every organization, every team should have a defined requirements change process. And this process can be simple or it can be elaborate, depends on the risk associated with having changes handled badly for your project. I think risk is a very good thing to consider when you're trying to determine, how complex do we have to make our processes. But any change process ought to deal with how do we propose changes, how do we hear about them? How do those get reviewed by appropriate people to understand their impact? Then the other appropriate people will approve them or not, and then incorporate the changes in all the affected work products. One way to think about this is to understand the possible states, the change states that you could be dealing with for a change request, and draw a state transition model that helps you see what are the allowed ways that we could go from one state to another. And I'll show you an example of this in just a moment. This is where we want to incorporate impact analysis, another topic we'll talk about very soon. I'm sorry to have to keep giving you these forward references to things that we'll talk about later in the presentation. I've been speaking for many, many years and training, and I've never yet learned how to say everything simultaneously, but we will get to all of these topics. Now, a very good idea is to support your change process with a tool, but remember, a tool is not a substitute for a process. I was consulting in a company once, and I asked them, well, do you have a change control process for how you handle requirements changes? And nobody said anything for a minute, and then someone said, we use Tracker. Tracker was one of the commercial change management tools you could buy. Well, okay, my question was, well, does everybody know how to use Tracker? Do they know what steps they're supposed to go through? Do they know what the life cycle is for a change request and how to communicate those changes with everybody, we used Tracker. They had a tool. They did not have a process to align with that tool. I have a simple philosophy that all change requests must follow the process. Now, this is just one of many reasons why I don't have any friends, I think. But I think it's a reasonable expectation. I used to run into this when I was working at Kodak in the research labs many years ago. I'd be walking down the hall and somebody would say to me, hey, I got an idea for a change to make in that system you guys are working on. I'd say, okay, what are you thinking? And they tell me about the idea, and I say, all right, that sounds good. So why don't you go put it into this change control tool that we use, and we'll take a look at it. And you know, I found that about half of those changes never showed up. And I'm thinking, well, if this isn't important enough to you to spend just a few minutes to use a simple form to request the change, then I don't care at all. And I wouldn't work on it. Now, I don't care how the change request gets into the system. I might tell this person, oh yeah, somebody else mentioned that to me yesterday. I'll put it into our change control tool when I get back in the office and we'll take a look at it. I don't care how it gets in there, but you have to follow the process. Otherwise, either the process is wrong for you, or people are just going to get right back into chaos by having changes coming in willy-nilly. And I'm going to remind you here that requirements changes might require renegotiating project commitments. Make sure the people who are asking you for changes understand that before you get into Dilbert land. So here's a little life cycle that you can define with a set of possible statuses that a change request could have at any time, and the allowed changes from one status to another. Okay, it's a life cycle. And this is a state transition diagram. Very old, simple technique, just boxes and arrows that you can use to show these things. So a change request starts out with a status of submitted. And all that means is, yes, it's come through an appropriate channel that we respect as a way that we get change requests. Maybe the appropriate decision makers ask somebody to go do a little impact analysis and evaluate this so we understand just what we're getting into if we say yes. And at some point we might say, well, that's okay, it sounds like a good thing to do, let's give it a status of approved. Eventually someone's going to do some work based on that change request, and that's going to then change the status to the change made. Now you might want to make sure the change is made correctly, so you do some sort of a review or other verification activity, and if it passes that, then you can go to a status of verified. And finally, once everything's all done, it's got a status of closed, and that change request has now been completely processed. So this is a happy path, the kind of normal flow through a sequence of statuses. But sometimes things don't go exactly that way. Like maybe when you try to verify that the change was made, so you can go from change made to verified, maybe the verification fails. So really you have to conclude, well, we didn't make the change properly. We have to go back to a status of approved and try again to get it right. Or maybe you have some sort of a shortcut so that for certain kinds of changes that are low impact, low risk, emergencies, whatever, you skip the verification step and you accept the risk associated with that. Okay, so that's a shortcut you might allow. Or maybe when you do the evaluation, it doesn't make it through the first cut, and you say, yeah, we're not going to make this change right now for some good reason, and so the status becomes rejected. Now, you don't throw it away because that might come back, but we want to at least have a record of the fact that we considered that change in its current status. Or maybe sometime as you're going through the process and working on it for one reason or another, maybe the customer changes their mind or the business changes its mind, and so it goes to a status of canceled, and we decide not to implement that anyway. So I think you might find it illuminating to track your distribution of change requests over time. And that'll kind of show you how much change activity is taking place and how quickly your team is responding to them. Now be careful not to define too many unique statuses. I was at a client site once and once saw a person there configuring their brand new change control tool. And he set up more than 20 change statuses. And even if they're all plausible, the fact is no one's going to use those. So I think about 8 like this is probably plenty. So the way a change control system typically works is shown here. We use a system very much like this that we developed in the Kodak Research Labs. I actually wrote this program with my own 2 hands. And we use this to let people submit bug reports or enhancement requests or requests for requirements changes in new systems, or simply asking for help. So you have this kind of tool that stores stuff in some sort of a database, and a user can submit one of these requests for some kind of a modification. It gets stored in the database, and it's then emailed that entry off to the appropriate people. There might be certain customer representatives, we call them product champions, who needed to know that someone had requested this change. There might be the support people who are going to be working on the project currently or supporting it if it's currently in operation. And it goes back to the user so they know their request has been received and what its status is and what tracking number was assigned to it. And then as we work on that request over time, then people can update the contents of the database, run it through its little life cycle of status changes, add any necessary comments, make changes in it, and those all get communicated back to the user so they know what's going on, the person who originally requested the change. And then also we could generate some reports from the database so that you could look at your change requests over time and see how we're going on working toward them. So this is basically how these kinds of tools work, and I think everybody ought to consider having something like that available. Now, one question that comes up is who makes decisions? Well, there's lots of decisions you have to make on a project, and deciding which changes to approve is certainly one of them. And the traditional name for the people who handle that is a change control board. Now, the term board scares people. It conjures up an image of time-wasting bureaucratic process overhead, but that's not necessarily a requirement. The change control board, the CCB, should be no larger nor more formal than it needs to be to ensure that the right people make informed business decisions about which change request to approve. And it's possible that one person might be fully empowered to do that on a small project. That's fine. Just make sure you understand on each project who are the people who are involved in making these kinds of decisions. So typically that's going to have be made up of a diverse group of people representing various functional areas, development and testing, project management, certainly a customer perspective, and others. Now those are not the people who are going to be informed about the decisions. Those are the people who are involved in making the decisions. And this group has to be authorized to make binding decisions. If they can only make suggestions and then someone else ultimately says yes or no, then that person is de facto the change control board and the others are just advisors. So it's a really good idea to adopt some kind of a CCB charter. And I have in the Process Impact Goodies collection a charter template. One page, very simple, that just helps you think through, particularly on a larger project with more people involved, who are these people? Who's involved with the team making these decisions? What is their purpose? What's their scope of authority? Is it just a portion of a project? Is it the entire project? Is it one project that's part of a bigger multi-project program? What's their scope of responsibility and authority? How do they function? How often do they meet? What's their decision-making process? That's a very important thing. We make lots of decisions on projects, but we usually don't talk explicitly, I think, about exactly how does a group of people make a decision. There's a lot of choices. Maybe you vote and it has to be unanimous. Maybe you vote and it's majority rule. Maybe you try to reach consensus. Those are all different. Or maybe you delegate the responsibility for making a decision to a certain key individual. There's no right answer, but every group should determine how they make decisions. And then how do we communicate the status of the decisions we made to the affected people? So typically these people will get a change request periodically and they'll look at them. They might request an impact analysis so we know how big the change would really be. They make and then communicate these decisions to accept or reject a change that's been proposed. And they might allocate these changes to set priorities for going into the backlog of remaining work to be done or targeting it for a certain release or an iteration. So this has to happen on every project. It's a question of whether you do it explicitly or just muddle along and hope that everybody knows how it works. Now, Agile projects do things a little differently than traditional projects have done that really should apply to everybody. They typically manage change by maintaining a dynamic backlog of work to be done. And by dynamic, I mean that the priorities in their change over time as business realities change. And this backlog contains work to be done, which includes things like user stories yet to be implemented, defects to be corrected, and business process changes to be addressed, maybe some training to be developed and to be delivered, anything that has to get done for the project to succeed. In each iteration then of the project will implement the appropriate set of work items from that backlog that have the highest priority on whatever reason you choose to assess priority at that time. Now, things happen. So we think we're looking ahead to say, what are we working on now? What portion of the backlog today? what are we thinking about doing in maybe the next iteration, and what are we deferring to some later iterations that we'll worry about at the right time. Now, as stakeholders request new work, could be new requirements to do or other tasks we realize we have to do, those go into the backlog and they're prioritized against the other contents in the backlog. You might come up with a requirement that you say, wow, that really has to go into the next iteration. That's important, or it's timely, or it's foundational, or whatever. And then other things that can just wait for the right time. So work that's not yet been allocated can be reprioritized or removed from the backlog at any time. So sometimes you decide we're not going to do something we once thought about doing, or sometimes a new high priority, say, user story could come in that might be allocated to the upcoming iteration, which therefore forces something of lower priority to be pushed into the past, or rather into the future, sorry. So that something that we thought we were going to do in the next iteration gets bumped down because now its priority isn't quite as high. So carefully managing the scope of each iteration through this dynamic reprioritization and deferral when necessary ensures that it's completed on time and with high quality. And really, I think this is how every project should manage change, whether you're officially Agile or not, dynamically based on priorities, because there's always an infinite amount of work yet to do, and we want to make sure we do it in the right order. So maybe you've had a conversation like this one. You're walking down the hall at work, and somebody stops you with a suggestion to make a change in a requirement for the system you're working on. And the request seems sensible as they're describing it to you, so you say, sure, no problem. But then you go back to your office and you start thinking about this requested change. And you start peeling away the layers of the onion, and the more you peel, the bigger the onion gets. Maybe you realize this is the exact opposite of what somebody else requested a few days ago. Maybe you realize this is going to be a lot bigger than I thought it was going to be when I was talking to that guy in the hall, but I said, sure, no problem. Well, the problem is that we say, sure, no problem, before sometimes we really understand and have thought about the request. So here's a little safety tip for you. Anytime somebody asks you like for an estimate for something like this, the right answer is always, let me get back to you on that. You want to make sure you understand it and think about it before you come up with some kind of an estimate or a commitment. So too often we make commitments to requirements changes without having worked out these real implications. So there are some checklists that you can use to help you think through just exactly what would happen if we say yes to this. And the goodies page of the processimpact.com website that I've mentioned does have a checklist and an effort estimating worksheet that you can use for these kinds of requirements change impact analysis. And a few of the items from the checklist are shown here. You might want to identify any conflicts this change would pose with existing requirements. You want to think about what are the possible effective design components if we've already started implementing a requirement. We get a change, well, do we have to modify some design that we've done or redo some code and make up some new tests? This is where your traceability data can be very helpful. The other thing we might want to do is to see what impact we're having on other things that are created. Oh, just a comment here. I see that somebody has raised a question that says they're having a timeout problem on processimpact.com. That may be that many of you are now visiting processimpact.com, and I mean, it's not exactly Microsoft.com, so you may be getting a timeout simply because of the capacity. So if you can't get into processimpact.com right now, please do check back a little later when not everybody is there at the same time. But thank you for your interest in that, and I do hope to find interesting things there at the website. Think about whether this change would affect any other systems or existing libraries of code. Are we going to have to review work products? Are we going to have to update various plans we might have created for our project? So the checklist just helps you do a more thorough analysis job. And in just a little bit of time here, you really know what you're getting into when you say, sure, no problem. And as with any checklist, you should modify these to suit your own situation. So there's a bunch of questions like that. And here's some other items from the impact analysis checklist. What impact would this change have on performance or other quality attributes like security? Sometimes a change might introduce a security risk, and that would be a very scary thing. Is it even technically feasible? Is it going to overload our computer resources? That's something you have to be careful of on systems that have finite capacity. Are you going to have to throw out any other work that's already been done? Would this change violate any business rules that are pertinent to the project or affect any other tasks that we're working on? So there's really a lot of things to think about here. And if you just think about them on the top of your head, you're going to miss stuff. So I find checklists very helpful to make sure that I don't overlook important things. So another thing you might want to do then is a little micro project planning for each of these proposed changes, so you can estimate how much work effort might you have to do for all of the bits of activities that you'll have to perform to satisfy that change. And then assemble those into a little bit of an overall cost, so you can really understand how much resources is going to take to get this work done, what order do those have to happen in, just like you would for any other project plan. And also, this is kind of important, think about whether that change would be on the project's critical path. By definition, if new work comes along or existing work is modified that is on the critical path, that affects the overall project schedule. So it's kind of nice to know that before you start saying, yeah, we could throw this all in, but sure, we'll still be done on time. And then you can estimate the cost and schedule impact from the effort. Now, you might say, well, this is a lot of work. That's silly. Well, for many kinds of changes, maybe it is unnecessary. But I've actually spoken to clients of mine who had cases and told me some kind of horror stories about change requests that were not analyzed for their impact. It turned out to be vastly larger than imagined, such that if they had done the impact analysis, the customer would have said, oh, okay, well, if it's going to cost that much and take that long, let's not do it. But they didn't learn that until they were already way into it, and so they threw away a lot of effort, and that's a pretty expensive way to run a project or an organization. All right, moving on to the next topic here, requirements attributes. I tend to think of a requirements spec as being three-dimensional. We've got this two-dimensional list of requirements, but then imagine that behind each of those requirements is another layer that gives you some additional descriptive information about each requirement to supplement the simple statement of intended functionality. So this is what requirement attributes are about. They let you store additional information about each requirement that's going to answer a lot of questions for people. Now, it's really cumbersome to manage several attributes in a textual document, but commercial requirements management tools make this easy. So some of the kinds of things you might want to keep track of are status. We'll come back to that in a minute. You know, what's the status of a requirement at any moment? What's its relative priority compared to all the other things we have to do? When was it created? What's its current version number? Who wrote it? Who's responsible for it if you have questions? Very good idea is to describe why is it there? You know, where did this requirement come from? I think various project stakeholders should always have the right to ask, why am I working on this particular requirement? And you should have a pretty good answer. And so one thing you might want to do is to record that origin or the rationale behind it so that people can preemptively answer the question. They don't have to go around tracking down the right person or make their own decisions that maybe say, oh, I don't think that's important, I'm not going to work on it. That's a pretty bad idea. So I think it's a very good idea to describe why a requirement, particularly one that's not obvious or is controversial, why is it in the requirement set? People might want to know, what is this targeted for? Is it part of a particular subsystem that we're allocating it to? Is it going to be going out in a specific product release or a particular iteration or build? That can be useful. You might want to think about the risk associated with a particular requirement, because when you're making trade-off decisions, do I do this or do I do that? Sometimes risk can influence your decision. You might decide to do something risky earlier rather than later to remove that risk, or you might decide not to do something risky because we want to get more stuff done that's lower risk that we know we can bang out. So you can think about it either way, but understanding specific risks associated with the requirement helps you make those kinds of decisions. How are you going to validate it to make sure that it's the right requirement and that it's properly stated? So let me warn you against trying to do too many attributes at once. You know, what happens sometimes is people hear talks like this and they hopefully get excited about some of the ideas, some of the techniques, and they say, oh, let me go try that. And so here I've listed, I don't know, maybe 10 possible attributes. Don't go back and then start creating 10 attributes for your requirements all of a sudden, because it will be a waste of time. You will fail. I would much rather see you look through a list like this or the more extensive list that's in my Software Requirements 3rd edition book and pick out maybe 2 or 3 attributes that you say, yeah, this would be really valuable for people to know. And that way you can focus on a small number of things, both to get people in the habit of recording that additional information, but also to help you learn how to manage it. You know, where are we going to store this? How are we going to track it and use it and communicate it? So the commercial requirements management tools will really let you use these attributes to your advantage. So for example, you could filter a set of requirements in the database to view just a subset that satisfies certain attribute characteristics. Like maybe you say, okay, I want all of the requirements that are allocated to release 7 that Carl is responsible for and that have a current status of approved. Okay, and you just get a little fragment of a requirement spec that's just a specific set of requirements. So this is a way that lets you mix requirements that are allocated to multiple baselines or releases in a single database and distinguish them from each other. So maybe if you have to defer a requirement, you just change the status attributes from one value to another. And that's a whole lot easier than moving it from one document to another. So that brings us nicely to requirement status tracking. And you know, typical project status tracking is kind of vague. A project manager might ask, hey Carl, how are you coming on that subsystem? And I say, pretty good, I'm about 90% done. And the manager says, weren't you about 90% done a couple of weeks ago? And I say, yes, but now I'm really 90% done. You know, this 90% done all the time joke is kind of a standard software joke, and unfortunately, it's sadly true way too often. Oh, here's another little software 90% joke for you. The first half of a software project consumes the first 90% of the resources. The second half of the project consumes the other 90% of the resources. So there's your software jokes for the day. So a better way to track project status, I think, instead of, hey, 90% done, no problem, would be to describe what percentage of the requirements allocated to the baseline have various statuses. I suppose my manager asks me, Carl, how are you coming on that subsystem? And I say, oh, pretty good. Of the 71 requirements, 35 are implemented and verified, 27 are implemented but not verified, and 14 are still not implemented yet, or whatever that adds up to. Well, I would feel like we had a much better handle on just what was involved with that chunk of work and where we were instead of saying 90% done. So here are some possible statuses that you might consider. Maybe it starts out being proposed, meaning the requirement was requested by some legitimate source that we respect. After it's been analyzed and the impact assessed, it might be allocated to a baseline and therefore has the status of approved. At some point, we're going to implement that requirement, meaning somebody did some design and wrote some code and tested the code, and we think, yeah, we've made that requirement happen. We do some testing or other verification activities to convince ourselves the requirement was implemented correctly in the product, and now it has a status of verified. But maybe along the way, for some reason, we decided not to implement a particular requirement, and so now it has a status of deleted. Or perhaps at one point the requirement was requested, but it was not approved, didn't make through the first gate, and therefore has a status of rejected. Now, rejected is kind of helpful because that lets you keep track of those requirements that might have been proposed at one point, kicked out, but then it comes back again. So that sometimes happens. They're like zombies. They're not always really dead. Now, sometimes people use a status of deferred, meaning like, well, we're going to do that later than planned, but I would rather handle that with a release number attribute, like I just showed on the last slide about the attributes. So if you've collected some information about your baseline set of requirements that were allocated to a particular project or release or an iteration like this, you can get some real insight into how you're coming on toward completion. And you could maybe track status over time like this. So this graph shows visually how the distribution of requirement statuses change over a 10-month project. You know, the requirement started out as being proposed, and at the end of that first month, maybe 85% of them were proposed, and maybe about 12% of them there were approved with the dashed light blue line, and then a few of them got deleted. We decided not to do them. And over time, you should start seeing them moving toward pretty much everything being either implemented and verified or deleted by the time you get to the end of the project. So I like these kinds of things that really let us know where we're going on things. Where are we at this particular moment? Requirements traceability, I think, is a really important technique for requirements management. We might want to be able to trace each of our individual functional requirements both backward to a specific origin, which could have been a higher level system requirement, could have been a use case or a user story or a business rule. But we also want to be able to trace them downstream into, this is called forward tracing, to the design and code elements that implemented each of those and the tests that we're going to use to validate them. If you don't know where a requirement came from, you might wonder why you're working on it. So it's good to know the origin here. Now, to do requirements traceability demands that each requirement is uniquely identified so that you can have a persistent label on a requirement that we can use as a name for it. Most people traditionally have used a hierarchical naming system, a numbering system, 3.1.4.2. But if you insert a delete a requirement, that can screw up the numbering, and the numbers don't tell you anything about the requirement. You could also just number them individually, like FR117 is a particular functional requirement, and nothing else would ever be called 117, even if we deleted that. Or you can use a text-based hierarchical naming system, like print.confirmCopies. Gives you an idea of what that thing's about, but it's a little bulkier. So however you choose to label them, this is what we're going to do. We're going to build a requirements traceability matrix. And this is a way to show the connections between requirements and other system elements. There are different ways to represent this. This is one way to show it. This shows us that requirement that we called FR117 eventually turned into a design element, maybe a circle in a data flow diagram called 8.8.7. And that eventually got implemented in a C program with certain functions in a C program, and we've got these test cases, action.1 and action.3, that link back to that requirement. Now, the fact that we filled this in doesn't mean that we've passed those tests. It just means we've written those tests and linked them back to it. So this is really a roadmap for the components of our system, and it provides a lot of useful benefits, I think. I don't know if you've ever had this experience, but I have. I got to the end of a project and realized I just missed something. I simply forgot about a requirement I was supposed to implement. And if you're filling this out as you go along, that can't happen because white space means work you haven't done yet. And if you fill it in, it's not white space, you know that you've actually addressed that requirement. This is kind of an at-a-glance status tracker that shows you what work has been completed and what work remains to be done. Now suppose a test fails. Maybe test action.3 does not give the expected result. You can say, oh, well, action.3 was linked back to FR117, and you bounce over to the source file and function columns, and that will help you point to the code to search for the problem. Now, it might not be right there. It might be someplace else or a side effect or in a library, but that's a pretty good place to start the exploration that we call debugging. Also, if a requirement change comes along, maybe somebody says, hey, we want to change what FR117 was all about. This can point to work you've already done in the designs and the codes and the tests so that you can efficiently figure out where we have to make changes because of that. Now, this is going to be very, very tedious to do manually on anything other than a small project. So you need to use a requirements management tool of some kind to store this information, and then you still need to define these logical links manually. So it's a combination of automation and manual effort and discipline. Now, you might think this is all unnecessary, but you know, I remember once when I first started talking about requirements, somebody had told me that they had done a complete requirements traceability matrix for the software for a jetliner, brand new jetliner, and that requirement spec for that was a stack of paper 6 feet tall. But you know, they did it, and if it's important enough, you can do it too. If it's not important to you, then don't spend time on it. That's your choice. So the requirements management tools show the traceability matrix a little differently. They'll have a table like this that shows the functional requirements may be connected to use cases, and you can set up these little arrows that show which functional requirements came from each use case. And then suppose you modify a use case, then you'll get some kind of visual indicator like this that shows, oh, you might want to go check the other end of those links and see if you have to update those requirements now to reflect changes in the use case. So we've been talking about documents, but you know, there are definite limitations to using traditional word processing documents. For example, it's tedious. How do you handle the requirements for multiple releases? Should that be multiple specs, one per release, or one growing spec, or what? It's difficult to move a requirement from one baseline to another as things flex during the source of the project. It can be difficult to reuse requirements information because it's all buried somewhere in a file. It's also difficult to link information from multiple locations. Maybe you have a piece of information that you want to reuse in multiple requirements, multiple projects, but that's not very easy to do because you've got these things all strewn around in these documents. And it can also be a little difficult to make sure that all of the stakeholders have access to the current version because the paper documents get obsolete and the electronic version can be more current, but they may not see the same things. So what we want to do is think about using requirements management tools for these. And I've just got some typical requirements management tool capabilities here. The tools do these a little bit different ways, so I'm not going to try to get into any specific tools. That's just not something I do. But typically they will help you manage versions and changes, so you can maybe maintain a version history of every individual requirement and define baselines as sets of those requirements. They might let you store requirement attributes, as we discussed. This is a way that you can define these traceability links to connect requirements to other requirements and to other kinds of components, which helps greatly with change impact analysis. And they usually have some kinds of access controls, so you can set permissions so that only certain people can make certain kinds of changes. So the tools sound great, but some things to keep in mind. First of all, I don't recommend specific ones because there's at least 35 or 40 of them out there, and I do not even attempt to keep up on what the capabilities are of each of those tools. Another thing to keep in mind is that they're not going to help you solve certain kinds of problems. So I've seen a lot of people who bought these kinds of tools and use them to some extent, but I don't think they're getting full value from the tool. So let me give you some suggestions about how to get the most from your requirements management tool if you choose to get one. First of all, they're not going to help you write good requirements. You have to do that yourself and populate it with them. There's an old tool or an old acronym from software from decades ago called GIGO, garbage in, garbage out. So just the fact that you're using a tool that lets you produce nice reports of contents doesn't mean that what's in there is any good. So don't even think about using a tool until you can already write good requirements. They're not going to replace a requirements process. These are requirements management tools, not requirements development tools. They're not going to help you get the right requirements or ask the right questions. You should expect some kind of a culture change when you're transitioning from traditional documents to a tool. Be careful not to overuse the tool. I warned you against creating too many kinds of requirements, too many attributes, those sorts of things. Expect to have to train the tool users. These things are fairly complex, and people need to be able to understand how to use them effectively. People have to have certain responsibilities with respect to how they're going to be using the tools as part of their team contributions. And take good advantage of the tool features. I once saw a company that had a very expensive high-end requirements management tool, and all they did with it was they took the requirements out of their documents, put them in the tool, set up these traceability links that we just discussed, and then they generated these big traceability reports, and it turned out nobody in the organization used them for anything. So that turned out not to be a very effective way for them to use the tool. So just a few caveats here. In my requirements book, I have a chapter on these kinds of tools, along with a lot of these suggestions and cautions about how to use them effectively. So we've covered a lot of ground here, I know, pretty quickly. I hope you got a few ideas of things that would be helpful for you in your organization. And the real reason we emphasize managing requirements effectively is to avoid the unpleasant surprise factor that happens at the end of so many software projects. My experience has been that surprises in software are never good news, and I would like to try to avoid those kinds of unpleasant surprises. So thank you very much for joining us today. And now Amit from Covair has a few closing remarks for us.
Yeah, thank you, Carl, for the lovely presentation, and I hope everybody found it very useful. So now, since you are aware of the best practices for managing requirements and might be wondering how to go about it and implement it. So this is where we from Covair would like to play a part and help you in implementing a task-based process-enabled requirements management practice. So with all our products, we help organizations to manage their requirements efficiently and ensure that they are correct right at the first time. So we have also arranged for 5 handouts which you can go through to gather more details about our products. And also I would like to invite all of you to visit our website to gather more details and also sign up for a demo. We will be happy to show how to implement the processes outlined by Carl and take care of requirement definition, requirement attributes, baseline, change requests, impact handling, version control, requirements progress tracking, as well as traceability. So with that, I would like to hand it over to Tracy.
Thank you, Ahmed, and thank you, Carl, for today's presentation. We're almost running out of time, but I do want to get in a few questions for Carl. We have so many. Carl, our first question is from Claus. He asks, what do you think about ending a change request process with a decision? If the decision to implement it, we will have new or change requirements. How will that be tracked as any other requirement? This avoids tracking items with two different processes.
Yeah, that's actually a problem because people typically are using one kind of tool to collect, issue reports and problem reports and change requests. And I think the thing to realize is that the change request then becomes the source of the requirement. So I don't actually have a perfect solution for that. You might have a tool that can integrate in fact, Covair can probably answer that question. If you can integrate the change request process with the requirement process so that a change request could feed right into an individual requirement. Otherwise, what I would do is I would look at the change request, and if maybe it's for a new requirement, I would write that requirement in the place where you keep all your other requirements. But for the attribute I called origin, where that requirement came from, I would trace that back to the change request. So that way you don't have to duplicate it, but you've got the link.
Thanks, Carl. Our next question comes from Wade. Carl, can you differentiate between a deleted and rejected?
Yeah, a rejected requirement didn't make it through the first gate. So someone proposed this requirement and said, gee, we'd like to do this. And for whatever reason, the decision maker said, yeah, we're not going to do that. So it didn't even get into the requirement set initially. It was just an idea that was considered and then rejected from further consideration at that time. A deleted requirement would be one that initially was approved for implementation, but then for whatever reason, as you got farther along in the project, you said, yeah, we're not going to do that after all. So it's really a matter of timing of when the decision was made not to do a particular proposed requirement.
Thanks, Carl. Our next question comes from Faraz. How do we transition from a requirement management process to a product management process?
Well, there are two different kinds of things, obviously closely related, but the product management sometimes is defined to encompass, all of what the requirement stuff does, but also things like product lifecycle and product families and, evolution of a product over time. So, and product portfolio management. So I would say that they're related. I would say that the product management is on a larger scale, more of a company viewpoint scale in the marketplace, say if you're doing commercial software, whereas the requirements management would be more on a project basis as opposed to a product basis. So we don't really have time to go into details on these things, but I would view them as two different yet related activities.
Thanks, Carl. We have time for just one more question from Fernando. What is the difference to collect requirements between Agile and SDLC environment?
Unfortunately, we just do not have time to go into that here. And you'll get raging debates and probably fistfights from that. But in my opinion, there is far less difference than there is similarity. And actually, you might go to the ModernAnalyst.com website, where last year my co-author Joy Beatty and I wrote an article called Agile Requirements, What's the Big Deal? And we talked about some of those things where they're much more similar than they are different. So rather than rehashing all of it here, I would point you to that article. Agile Requirements, What's the Big Deal?
Excellent, Carl. Thank you. We have run out of time, so I will close out today's webinar. Carl, again, was such a great webinar, so thank you. And we'd like to thank Covair Software for sponsoring today's event. Thank you for attending today's Modern Analyst webinar. I'd like to remind everyone that today's webinar, along with the slides, will be archived at ModernAnalyst.com within the next few days. For those that are asking for PDU and CDU information, you can also find some information on the ModernAnalyst.com website. This concludes today's event, and thank you. Have a great day.
Thanks all. Bye-bye.